Hi friends, welcome to the Unit 2 Day 3 notes. We're going to be continuing on with x-intercepts, y-intercepts, and then finding them for an equation. To find an x-intercept, what we do is we set y equal to 0 and then solve for x. Similarly, if you want to find a y-intercept, you set x equal to 0 and then solve for y. So for solving for x or y-intercepts, essentially you're plugging in x for that other value or number, that other variable, and then you can solve it to find it. So for this one, to find the x and y-intercepts of the following, for the following equation. So what I'm going to do is I'm going to plug in for, to find my x-intercept, I'm going to plug in 0 for y. So to find the x-intercept, I'm going to set y equal to 0. So that gives me 6 times x plus 5 times 0 equals negative 25. That gives me 6x equals negative 25. Divide by 6 on both sides. And I get x equals negative 25 sixths. So because this is my x value or x coordinate, my y value for this is 0 because it is an x-intercept. So this is an actual point on the graph, negative 25 sixths, comma 0. I forgot to grab my calculator. Doing negative 25 sixths, I don't know that. So again, always make sure you have all the tools that you need before you start recording. This is probably the 15th time I've done this so far. Alright, so if I take negative 25 divided by 6, I get, again I spoke about this earlier, but we want to use the repetan bar, negative 4.16 repeating, comma 0. Might help if I need to graph it, kind of a good approximation of where to graph it. So now to find the y-intercept, we plug x equals 0. So I have 6 times 0 plus 5y. Sorry, a little bit close there. Plus 5y equals negative 25. So 6 times 0 is 0. So I have 5y equals negative 25. Divide by 5, divide by 5, you get y equals negative 5. So my y-intercept is going to be 0, comma, negative 5. I don't need to convert that from a fraction to a decimal because it is in both. Next page. This next page, it talks about taking the two intercepts we found in example 2 to write the slope of the line through these 2 points. Then write the equation with y in terms of x. So what I'm asking to do is now we're trying to find the slope of this value. So here, finding the slope between 2 points, we can subtract, find the difference of these. So if I take I'm just going to rewrite them on this side because I think it's going to be easier to process. Let's see, I've got negative 25 sixths, comma 0, and my y-intercept was 0, comma negative 5. Okay, so when you're subtracting, we're talking about the change in y's over our change in x's, delta y over delta x. So we're going to talk about negative 5 minus 0 over 0 minus negative, so plus 25 sixths. So that gives me negative 5 over 25 sixths. All right, so the issue here now, we have a compound fraction, fraction within a fraction. So to reduce, negative 5 over 1 divided by 25 sixths. Whenever you have a fraction within a fraction, going back to a previous course, you multiply by the reciprocal. So this is going to be negative 5 over 1 times 6 over 25. We have some reducing that we can do here. So this is going to give us negative 6 fifths for our slope. So our slope is negative 6 fifths. This particular problem, it actually would have been easier just to return back to the standard form problem that we had, minus 6 on both sides and then divide by 5, and then we get negative 6 fifths. So that would have been easier. It's good to see multiple different ways to approach it. This is how to find the slope between 2 points. We'll write the equation of the line with y in terms of x. This is going to be y equals negative 6 fifths x, that's the slope, and then for our y-intercept, minus 5. And this is what you would have gotten if you converted from the standard form over to the slope-intercept form. This is in slope-intercept form. Compare the slope and the y-intercept you found in the original equation given. Do you notice anything? Is there a rule for finding the slope and y-intercept from standard form? So if our equation in standard form is going to be ax plus by equals c, then if you can think about like what you're going to do mathematically, and so if I'm solving for the slope, if I'm trying to get the slope, so if I look at this, I'm going to, we'll just do this off to the side. If I have ax plus by equals c, so if I want to find the slope, I'm going to convert this to slope-intercept form. So I'm going to subtract ax on both sides. So I have by equals negative ax, or opposite ax, plus c. We'll call this opposite because it could be positive, it could be negative. Then if I divide both sides by b, so if I think about this, my slope here is going to be y equals opposite a over b, then x plus whatever c over b is. So your slope in this case is going to be opposite a over b, and your y-intercept is going to be 0, comma, and then c over b. And this works for any equation. From standard form, you're trying to find the slope in the y-intercept. Write each equation in slope-intercept form, lay the slope and y-intercept, then graph and get one more point on the line. So again, we're going to talk about converting this over. If I think about the term that we just had up here, 1 is the value in front of y,